All right, let's just jump right into a pretty wild engineering problem. How on earth do you weld something perfectly at the bottom of the sea?
So picture this. You've got a critical oil pipeline, maybe part of a huge deep sea rig, and it needs a fix. Now you can't just, send a guy down with a standard welding torch. The pressure alone would be insane, not to mention the cold, and, well, all that water. It seems impossible, right? So how do they pull it off?
Well, the answer, and you probably guessed this, involves some seriously cool tech. Check this out. This is the exact experimental setup that scientists at the Harbin Institute of Technology put together to crack this very problem. We're talking a robot, a super high-powered laser, and just a ton of clever thinking.
And you gotta understand, the stakes here are massive. This isn't just some lab experiment for fun. We're talking about infrastructure that's absolutely essential. The old ways of doing this, like arc welding, they just don't cut it down there. The arc itself is all over the place, and the cold water cools the weld way too fast, which leads to all sorts of cracks and defects. And on top of all that, it's just flat out dangerous for the human divers who have to do the work.
Okay, so if the old way is so problematic, what's the new plan? Well, scientists decided to bring in the big guns, a tool that's way more precise, way more powerful. Yep, the laser.
And really, the difference is like night and day. Arc welding, super unstable, prone to defects. But a laser beam, it's rock solid. And here's the best part. You can operate it remotely with a robot, taking people completely out of harm's way. And the most important thing is that it gives you this super precise, controllable blast of heat. That's the secret sauce for a really strong, clean weld.
But you know how it is, it's never that easy. Even something as futuristic as a high-powered laser hits a few major snags when you take it underwater.
So, here's the deal. A laser beam is so incredibly focused that everything has to be lined up perfectly. If there's even a tiny, unexpected gap between the two metal plates, the whole weld could be a bust. Plus, that laser is so powerful it can actually vaporize some of the metal it's supposed to be joining. This can cause all sorts of weaknesses.
So how do you get around that? Well, the first part of the fix is actually pretty brilliant. You just add a filler wire. A robot carefully feeds this thin metal wire right into the laser's path. It melts, fills in any of those gaps, and replaces any metal that got vaporized. Boom, you get a much stronger joint. All right, so we've got our robot, our laser, our handy filler wire. We're all set, right? Haha, not even close. The biggest enemy, the final boss of this whole operation, is still everywhere. It's the water itself. And this is what happens when that enemy attacks. Just look at that weld. The second that super hot molten metal touches the cold water, the water instantly flashes into steam. That steam gets trapped inside the weld as it cools, and you're left with this ugly, lumpy mess full of tiny holes. And that doesn't just look bad, it makes the weld dangerously weak.
Okay, so you can't get rid of the entire ocean, obviously. But what if you could just get rid of the water right where you need to work? That became the goal, to create what they call a local dry cavity. The best way to think about it is like making a tiny temporary force field, a bubble of gas that shoves the water aside just for a second, giving the laser a perfect little dry spot to work in.
And how do you make that magic bubble? With this. This is the secret weapon. It's a totally custom-designed, double-sided gas-shielding nozzle. Now, I know it looks complicated, and it is, but what it does is pure genius. Its whole job is to create that perfect dry bubble, not just on top of the metal, but on the bottom too.
So how in the world does this thing work? It's basically a three-part system. First, you've got an outer jet of compressed air that's like a bouncer at a club. Its job is to just muscle the bulk of the water out of the way. Then, an inner jet comes in and floods the area with argon gas. Argon is inert, which means it won't react with the hot metal. And then, and this is the really critical part, a whole other nozzle underneath does the exact same thing to protect the bottom of the weld. And the result? Wow. Just look at the difference here. On the left, that's the weld without the gas shield on the bottom. Remember that porous, bubbly mess? There it is. But on the right, that's with the gas shield doing its thing. It's smooth, it's clean, it's perfect. The difference is just, it's unbelievable. Now, the researchers didn't just guess this stuff. They tested everything, and they found there was a just right amount of gas flow for that bottom nozzle, kind of like a Goldilocks situation. Too little gas and water sneaks back in, but too much gas and you actually create other problems, like turbulence that messes up the weld. The magic number they landed on, 50 liters per minute. And at that perfect flow rate, everything just clicks into place. The nozzle creates that stable, dry pocket on the bottom,
and the laser and the filler wire can finally do their jobs in this perfect water-free zone. And the result is a flawless weld, with none of those nasty little holes from water vapor.
And we don't have to just take their word for it. We've got the numbers to back it up. Let's talk tensile strength, which is really just a fancy way of saying how hard you can pull on something before it snaps. Without that bottom gas shield, the weld broke at around 505 megapascals. But with that perfect 50 liters per minute flow, it jumped all the way to 670. That is a huge leap in strength.
And this is what it all comes down to. In the scientists' own words from the paper, the weld was so good its strength approached those of in-air joint, basically. I mean, that's it. That's the holy grail. To make a weld underwater that's just as good as one you could make in a perfect dry factory.
So when they put them head-to-head, the final showdown, the differences were tiny. The underwater weld was a little bit narrower, and that's just because the water around it still cools things down faster. But where it really counts, in pure strength, it was almost identical to the perfect weld made in the open air.
And if we zoom way in, down to the microscopic level, you can really see it. On the left is the underwater weld. See that tight, refined grain structure? That's from the faster cooling. It looks a little different from the in-air weld on the right for sure, but the key thing is, it's just as solid. No defects.
So, at the end of the day, mission accomplished. It took a laser, a filler wire, and one incredibly smart gas nozzle, but the researchers pulled it off. A top-quality, totally defect-free weld. On stainless steel, completely underwater. And that just leaves us with one last really interesting question, right? If they can pull this off in a lab, how long until we see fleets of robots like this out in the deep ocean, fixing our most critical and hardest to reach infrastructure all on their own?